In this question, you're going to learn how to use the density of the mass. Now I'm going to read the question first, and I'm also going to explain how to solve these type of questions step by step. And also, sometimes I'll also draw a diagram so that it's going to be helpful for you to understand. Now the question says the planet Venus may be considered to be a sphere of uniform density. The gravitational field strength at the surface of the Venus is 8.87 Newton per kg. Now this is the question. This has got a couple of facts, and you have to make a note of the density and also given the gravitational field strength at the surface of Venus. Now this is what you're supposed to do. Show that the gravitational field strength Gs at the surface of a planet is related to the density and the radius of the planet by the expression gravitational field is equal to 4/3 pi g rp. And these type of questions are very easy. You can easily get 2 marks if you understand this question. Now in my earlier videos, we know the definition or the formula to find the gravitational field. We know that gravitational field is equal to capital G m by r square, where r is the distance from center to the surface, or r is the distance from the center. Now this is the standard equation. So here we have to show that the value of G equals this bit. Now, so I've got a diagram here. This is the mass of the Venus, and this is the radius of the Venus, and this is a point on the surface, and the question says the gravitational field is 8.87 at this point. So here, in order to use this standard equation, we must know the mass, but the mass is not given in the question. However, we know that mass is related to density and the volume using this expression, density equals mass by volume, and mass can be found out by the density. This is the formula, the density times the volume, 4/3 pi r cube. So now we got the expression for mass. If I substitute the value of m here, I will get G 4/3 pi r cube density divided by r square. If you rearrange this, you get 3r square in the denominator and the rest on the numerator, and these will cancel away. This will give you just one single r in numerator, and once you tidy up, you will get this 4/3 pi g r rho. So look at that. Now this problem is a bit of a algebraic type of problem. You have to know, basically the important thing in this problem is to know that the density equals mass by volume, and you should also know the formula of the gravitational field Gm by r square. So these are problems you can easily get 2 marks. The second question is related to the first one. It says calculate the radius of Venus. Now you can use many methods here, but however, we already know that Gs, the gravitational field, is equal to 4/3 pi g rp. Now we know there is in this expression there is a radius of Venus here, r. You just have to rearrange this expression and make r as the subject. You'll end up getting r equals 3gs by 4 pi gp. And substitute, the value of G, which is 8.87, and all the values, this is given in your the data book, and this is given in the question. If you substitute, you'll end up getting a value something like 0.06058 times 10 to the power of 8. Now the question also says give your answer using appropriate significant figures. Now how do you decide how many significant figures you need? If you look at the question, all these values, they use only 3 significant figures. So you can just use the same significant figures here. So you can convert this to 6.06. So when you take the 3 digits here, you can round this. This rounds to 606, so I end up getting 6.06 times 10 to the power 6 meters. Now by doing this, you can easily score 3 marks. So just keep in mind that sometimes these questions, okay, you have to understand the first thing. The second question is to graph the gravitational field strength from going from one planet to another. I have explained this in my first video, and here if you read this question, it basically tells you that you have to use the proper values for the gravitational field. Again, what I've done is, this is the Earth, and the gravitational field of Earth is 9.81, and we already seen in my earlier videos the graph for gravitational field has the same shape as 1 by x square. So 1 by x square, the curve goes like that. And here, so I've started for 9 point. What I did here is, so I want to show these values, the height of these values. So I divided this line into 10 equal parts, and I've taken 9 point, actually supposed to be over here. So 9.81, it's somewhere here. So starting from there, it goes all the way here and reaches 0, and this is the point where the gravitational field due to Earth is 0, and the gravitational field of the Venus kicks in from here. So here it's 0, and from here you can continue the line showing this increase in the gravitational field as you approach Venus, and it ends in 8.87. This is the value given in the question. So you have to make sure you use these numbers on the graph. And also what I've also done here is, this horizontal line I divided this the distance, the midpoint of this line. Now I know that the gravitational field of the Earth is stronger than Venus. So if you want to show the 0, the point where it's going to be 0, it has to be somewhere away from this midpoint. So because Venus gravitational field is less than Earth, and the effect of Earth gravitational field should be more compared to Venus. So this distance where it is 0, is after the midpoint, and this is the shorter distance compared to this. You can also find the precise point where the gravitational field is going to be 0. So you can find this point by using a simple mathematics here. So what I've done here is, I've got Earth and the Venus here, and I've just drawn a line, start from the center up to here, and I've taken a point P where the gravitational field, the net gravitational field, is 0. Now I would like to cover a bit of a concept about this in my next video, because all this time I never mentioned that gravitational field is a vector quantity. So gravitation field is a vector quantity. Now that's the concept I'm going to talk in the next video. So just to give an overview of how to solve these type of problems, what I've got here is, I've got a point P, and I've taken just a random distance of 10 units, and I've also taken the distance from Earth to this point is x, and the remaining distance from P to here is 10 minus x. This is a basic algebra. Now because gravitational field is a vector, I'm going to use this arrow here. Now this is the gravitational field towards the Earth, and this is because of Earth, and this is the gravitational field because of Venus. If we say that at this point the net field is 0, then obviously the magnitude of this this side of the field must be same as this side. Let's see how to solve these type of problems. Now this is the equation, a standard equation to find the gravitational field. E, this is the because of Earth, is equal to m gme by x square, because x is the distance of the point P from the center of the Earth. On this side you got the gravitational field because of Venus is gmv by 10 minus x square. Now keep in mind this point, this distance is 10 minus x square. Now at this point, if this point have to have a 0, then these two values must be the same. So EE must be equal to EV at point P. If you substitute gme by x square is equal to gmv divided 10 minus x square, g will cancel away. If you simplify this, in order to get the value for x, you must know the value of the mass of Earth. This is given in your data sheet, and the mass of Venus, this information is available in the question itself. So in the question you are given the density of Venus, and we also found the radius of Venus in the earlier question. Now you can apply this formula. Density is equal to mass divided by 4 by 3 pi r cube, and you can find the mass of Venus. When you substitute and solve for x, so you'll end up getting x is approximately equal to 5.5. Now what this means here is the point where the gravitational field, the net field is 0, is 5.5 units away from Earth, or 4.5 units from Venus. Now this is very obvious because the 0 point must be a little bit away from Earth, and also the mass of Earth and mass of Venus are more or less, there's no much difference in these two. So for that reason the 0 point is just after the midpoint.